Hello folks, it's just only me again. Thought I'd take the opportunity to show you another little trick that I learned a while back that I've always found to be quite useful. And this one has to do, I also learned this from my composition professor at the University of Illinois, Paul Zonn. And just thank you, Paul, etc., etc. And it's a way to discover whether or not a progression of pitches has any inversional combinatorial versions of itself. So, and what I mean is this. Say, for example, let's imagine that we have the following progression. We have D, natural, A, I'll show you this in a minute, A, E flat, B, and E natural. Okay, so there is a little 5-note progression. And we'd like to try to discover whether or not there are any inversions of that interval sequence that are combinatorial with that progression of pitches. And what I mean by combinatorial is that somehow the intervals, the intervals stay quote unquote the same, but the pitches are completely different. Okay, and there is a way to do that that does not require you to remember long, unending rows of meaningless digits of the kind that, or at least to me, meaningless digits, such as you'd find in like serial composition and atonality. You don't have to remember all of those. Mind you, you don't have to remember them anyway to look them up, but you don't have to have access to this. It's a nice little, basically, it's a nice little process that you go through. And the idea is called odds and evens, whereby you take all the odds and add them to the evens, and the missing odd is combinatorial. Let me show you what I mean. All right, so odds and evens. This thing I learned to refer to it as odds and evens. Now, the first thing you want to do is you want to measure in semitones the distances away from each of the notes in that series, or whatever series you're working on. So D, A, E flat, B, and E natural. Taking D as the 0 point, already sounds like a bloody algebra class, don't it? All right, so 0. And we notice that A is a perfect fifth away from that, and a perfect fifth away from, in terms of semitones, is 7. 7. We notice that E flat is a 1 semitone away from D natural. 1. And then B is in boy. B is in like the B minor mass. That B is 9 semitones away from D. And E natural, of course, is 2. So what you have there is A is 7 semitones away. E flat is 1 semitone away. B natural is 9 semitones away from D natural. And E natural is 2 semitones away from the opening pitch D natural. Okay, and you notice that you've got both odds and even numbers there. You've got 9, 1, and 7, and 2. So there are 3 odd numbers, and there's 1 even number. And what you do is you add the odds to the evens. So, for example, you've got a 7 as an odd number, you have a 1 as an odd number, and you have 9 as an odd number, like so. Now, add 2 to each one of those. Like so, adding 2 to each one And what you get, 7 plus 2 equals 9. 2 plus 1 equals 3. 9 plus 2 equals 11. All right, and you'll notice that you've got the product of those things. You now have more, you have the odd numbers that you have already are as follows. 1 in the sequence itself, 3, right, over here in one of the equations. You have 11, and you have 7. So the missing odd number is 5. 5. So, and it turns out that 5 semitones away from D natural is G. G. That G is 5 semitones away from D. And if you produce an inversion of your first 5-note group, you'll discover that you'll come up with this. You'll have in the original, you have perfect fifth up, tritone down, right, etc., etc. Okay, so so instead of going perfect fifth up, you go perfect fifth down. And then a tritone, instead of a tritone down, a tritone up. And by doing that to the rest of the intervals in the original 5-note progression, you come up with this collection of pitches. In other words, G, C, F sharp, B flat, and F natural. And that inversion is combinatorial. In other words, no pitch content is shared between the original and its inversion. So those two 5-note progressions are combinatorial. Okay? Combinatorial. No pitch overlap, but intervallic relationship is somehow preserved. In other words, this intervallically is that inverted. Okay, now, something else that's kind of interesting, something that I sort of thought of, was that if you do a quick count, like literally just take the chromatic scale and just do a quick count. Here's the chromatic scale down here. You do a quick count of the notes that you've already used up. It turns out that what you have left is as follows. You have C sharp and G sharp that don't appear already in these pitch progressions. And it's kind of interesting that if you, for example, take the G sharp and put it on the back end of the P0, shall we say, P0 prime 0, right, we get this, right? So you've got that, a major third up from E, right? And if you take the C sharp and respell that as D flat, and tack that onto the hind end of the combinatorial inversion, you get this, a major third down. So these, you have now very easily produced a 6-note progression, and it's combinatorial. It's a combinatorial variation of that that progression that's inverted. So a prime and an inversion of that, or an inverted variation of that sequence, which is inverted, and which you can then go together, and then you can maybe use that as the basis of a 12-note section. Maybe you could use it some other way. But nevertheless, I think that this is a really quite convenient and a lot less remembering a way to discover inversional combinatorial than others that may or may not exist. It's something I've always found very helpful. And just simple arithmetic and measurement away from a 0 note. And it's very, very quick and very, 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 very convenient for me. Anyway, I thought this might be of some interest to some of you. Hopefully it is. And thank you very much for listening, and I will see you around. And from then on, bye for now.